Okay, so now I want us to find a profile, but more an analytical profile. We know by definition, okay, we have the open measurements, which is equal to y is equal to the sum of x of mx, variety of x, and rho x. So yeah, and we know also like that mx is just equal to 2/3 of theta I theta I to the precedent question, where we did is optimal probability measurement, and so we have this is equal to 1/3, and so we just have the sum of x of 1/3 multiplied by 2/3 of theta I theta I theta I, and so it's just equal to 2/9 like this is equal to so on, because it's normalized, and so it just gets this, which is equal to 3/3, 3/2, like, because theta I is equal to 3/2I, so just 3/2I, and so it's 6/18I, so just 1/3I, and hence like y is emission, and satisfies y superior to 1/3 of theta I, theta x to be precise, for every x, and so it's dual feasible, and so because it's feasible, mx x must be optimal. Like if you want to check, like you'll see like trace of y is equal to 2/3, which agrees with the we found Oslo, right? Just like a sanity check. Like it just is, because like we have just found that y just trace of 1 year, 1/3 of I, so we just take this out. And so if you just this, like trace of I is 2, and so you just have 2/e, and yeah, we find the value like that we find numerically, and so it's correct. And maybe we should add this was correct because like 1/3/I, and so I like his value is like between always equal to 1. Here it's between 0 to 1, and so we're just saying like in the end why this to this, and so it's true because like always superior to or equal to 1, and here between 0 and 1, so that is true. That's it.